In this video we're going to be going over a new method of simulation in RandFlux, which is going to be circuit simulation. And the basic circuit itself is very basic, as it's going to have a DC source, an AC source, and an electrochemical device. So what we're going to be using is that we're going to be using the electrolysis project file from the previous example for our electrochemical device. So next first we're going to create the circuit itself. Press R to rotate the source. Press escape as well to end the selection. And this is going to be our unknown element. We load the file, cell1 device file. And this is from the electrolysis project. So we're going to now connect everything together. Add in the probes. Next we're going to be renaming this I DC, since it's a DC source, and since we're already here, we're going to be changing the value to be 1E -3 or 1 milliamps for the DC source. Gonna move this over here. Gonna be changing this to be IAC since it's the AC source, and we're going to have the value for this be 1 since it's the normalized value for our small signal analysis, just for easy calculation of the EIS. I'm going to change this name to be VDC since it's next to the DC source, and this one's going to be named VAC. And we're also going to be changing this to be checking for AC as well. Move this over. Now we're going to do the circuit simulation. So in this case, we go to simulate and then do new numerical simulation. Move this over. Now we're not gonna be needing any of these. Oh, don't click that. Or this as well. So the first thing that we're going to do is that we're going to be doing is sweep variables for calculating the mass transfer of the electrolysis. So we're going to be sweeping this over time from 0 to 3600. The initial step is 60 as from the previous project or example, and maximum step is going to be 600. I'm going to be plotting this. Mass for the plane name, and this we're going to be doing the anode first. This is going to be time. This is going to be multiplied by 6.94 since we're only getting this since that's molar mass. This is good. Next is going to be the cathode. Press OK, and just so we don't forget, I just noticed that I forgot to put in the ground for this circuit. So next we want to save this circuit. We're going to rebuild the circuit now on our job file, and next we're going to be saving the job file itself. It's going to be a circuit 2 cell jobs. We're not going to need this at the moment. And there, plot the mass transfer, similar to what we saw in the electrolysis example from when we first did this. Next thing we're going to be doing is that we're going to be doing the EIS for this. So, as we already done before, we're going to set the variable. We've already created a frequency itself, and the frequency is going to be 1e to the -3. The small signal analysis, we don't really need to change anything other than make sure that the frequency of variation is going to be f. The parameter is going to be only AC sources, as we are using the AC source of what's in our circuit as it is. Next we're going to be adding in the plot. EIS, impedance. And this is where we're going to be doing something different. So in this case, we're going to be doing curly brackets real VAC over IAC, and then we're going to end the curly brackets, and that's going to be our resistance, and this is going to be our reactance. So we're going to be doing negative imaginary VAC over IAC. Make sure to do this as how I've labeled it on the example with the commas and the curly braces. And then the next thing that we're going to be doing is that we're going to be having that frequency increase with each step. Oh, not that. Set variables. We could have f 1.1 times f. Move that down. And then we're going to be adding in the repeat step for the job file. So we're going to have this do it 10,000 times. Oh wait, no, not there. This is going to be doing the previous 3 jobs, and we're going to have it repeat this. Oh, not there. 10,000 times, with the constraint that as long as f is less than 10,000 hertz. And then we run this. Oh, to speed it up. Change that. And that's the EIS using the circuit simulation method.